Practice 3-1. This is the practice for the Module 3 exam. For problems 1 through 3, solve the equation negative 2x squared plus 7 equals 1 using the indicated method. So what we'll do first is we'll say f of x equals negative 2x squared plus 7, and we'll let g of x equal negative 1. So let's go ahead and we'll plot that g of x. Negative 1 is right there. And now we'll plot f of x. You got a plus 7, so we're going to be 7 on it. And then it's going to be right here and right there. And I got that right off the old calculator there. And it goes like that. Anyway. And like that. All right, so there's your point of interest, and there's your point of interest. So x equals negative 2 and x equals 2. Solve by factoring. We have negative 2x squared plus 7 equals negative 1. So to factor, we're going to need everything on one side, so we'll add 1 to both sides. Negative 2x squared plus 8 equals 0. And then greatest common factor of negative 2, take negative 2 out, and you got x squared minus 4 equals 0. What are the factors of 4? Or negative 4? That would be 2 and negative 2. So you got negative 2 times x minus 2 times x plus 2 equals 0. Let's fix that up a little bit. Plus 2 equals 0. All right. So we'll set x minus 2 equal to 0, and we'll set x plus 2 equal to 0. Solve for x. You got x equals 2, and x equals negative 1. Subtract 2 from both sides. So again, we got x equals negative 2 and x equals 2. Two different methods, same result. Solve by taking the square roots. So if we have negative 2x squared plus 7 equals negative 1, we're going to subtract 7 from both sides, and we get negative 2x squared equals negative 8. We'll divide both sides by negative 2. We got x squared equals 4. Now that we've got x squared by itself, we can take the square root of both sides, and that'll give us x equals plus or minus 2. So again, x equals negative 2 and x equals 2. Either way you do it, you still get the same result. Good. All right. Number 4. Find the square of each imaginary number. So what do we need to do first? Well, we got to square both sides. So we got to square the 4i, and that's going to give us 4 squared times I squared. 4 squared is 16, and I squared is negative 1. So our answer is negative 16. Now we have I times the square root of negative 11. So if we square that, that will give us I squared times the square root of 11 squared. And that's going to be negative 1 times, and the square root of 11 squared is just 11. So that's going to give us negative 11. Now let's square this one here. So that's going to give us I squared times the square root of 7 squared over 3 squared. Okay, and that will equal, well, I squared is negative 1 times, and the square root of 7 squared is 7 over 9, and that will equal, well, negative 7 ninths. Not a problem. And let's take a look at number 7. Determine whether each equation has real or imaginary solutions by solving. Okay, so let's see here. Let me get myself a little real estate down here. And what do we got? We're going to do these by solving. So I'm going to add 12 to both sides. And I get 7x squared equals 12. I'm going to divide both sides by 7. I get x squared equals 12 over 7. Take the square root of both sides. And we have x equals plus or minus the square root of 12 over the square root of 7. Well, the square root of 12 would be x equals plus or minus the square root of 4 times 3 over the square root of 7. And the square root of 4 is 2, so we get x equals plus or minus 2 times the square root of 3 over 7. So x equals 2 times the square root of 3 over 7, and x equals negative 2 times the square root of 3 over 7. Good deal. What about number 8? I'd subtract 9 from both sides, and that gives me x squared equals 3. Well, subtract 9, that's going to be negative 6. Negative 6. All right, now that we've got the x squared isolated, we'll take the square root of both sides, and we get x equals plus or minus the square root of negative 6. Well, 6 is, well, the factors are 1, 2, 3, and 6, and it can't be reduced anymore. But the negative 1 can be taken out, so we have x equals plus or minus I times the square root of 6. So our solutions are x equals I times the square root of 6, and x equals negative I times the square root of 6. Looking at 9, I'm going to distribute the 2 in first. I get 2x squared minus 2 equals x squared minus 3. So I'm going to subtract x squared from both sides, and I get x squared minus 2 equals negative 3. I'm going to add 2 to both sides. I get x squared equals negative 1. Now that it's isolated, I can take the square root of both sides, and I get x equals plus or minus the square root of negative 1. Well, the square root of negative 1 is I, so x equals plus or minus I. So x equals I, x equals negative I. Excellent. Excellent. Number 11, recall the equation for falling objects h of t equals h sub 0 minus 16t squared, where h is the height of the object in feet at any time t in seconds, and h sub 0 is the object's initial height in feet. Use this equation for problems 10 and 11. All right, so we have a carpenter dropped a hammer from the rooftop 48 feet, so this is h sub 0, okay? That's the initial height. How long did it take the hammer to hit the ground? So we have the ground, that's where it ended up, so that's going to be 0 equals, and I'm getting 48 minus 16t squared. All right. I'm going to add 16t squared to both sides, equals 48. And then I'll divide both sides by 16. I get t squared equals 3. Well, let's take the square root of both sides. And we get t equals plus or minus the square root of 3. The square root of 3 cannot be simplified, and it can't be a negative because we're talking about how long it took. So t equals the square root of 3. That's the exact solution, and the approximate would be 1.7. That's the square root of 3, control, square root, and then we put 3 in there, press enter, and we get 1.7. So 1.7. An acorn fell from a branch 20 feet high and landed on a branch 7 feet high. So here's the initial height, and then there's where it stopped. So we're going to have 7 equals 20 minus 16t squared. So I'm going to subtract 20 from both sides. I get negative 13 equals negative 16t squared. Divide both sides by negative 16. I get 13 over 16 equals t squared. So let's take the square root of both sides. And I get, equals t. And this is going to be plus or minus. And the square root of 13, now the square root of 16 is 4. So there's my solution. T equals the square root of 13 over 4. It can't be negative because we're talking about an amount of time. The square root of 13 divided by 4, if you put that in the calculator, it is going to be approximately 0.9 seconds. It's 1.7 seconds. All right, folks, great job on 3-1. Now let's practice 3-2, complex numbers. Write each expression as an imaginary number. Okay, so square root of negative 25, that's going to be the square root of negative 1 times 25. Well, 25 is 5, the square root of negative 1 is I. Not a problem. What about here? Number 2, 3 times the square root of, it's going to be negative 1 times 49. So we're going to have 3, and then square root of 49 is times 7, and then the square root of negative 1 is I, so I get 21I. Not too shabby. What about here? We've got negative, and then that's going to be the square root of negative 1 times 81. So we got negative, and then the square root of 81 is 9, and the square root of negative 1 is I. Okay. Now we can do these in the calculator. Let's go to our calculator, and let's just type, we got negative square root of negative 81. What happens? We get negative 9i. Is that not what we got? All right. Sometimes if the settings are different, let's see here. Let's go up there and grab it. You might get something that looks like this. All right. Same thing typed in, and it says non-real calculation. All right. If you get that, you need to go doc 7 2 and change it from real to rectangular. Press OK. And then you can go up there and grab it, and that will fix that. All right, good job. Good job. So let's try. For each, identify the real part. Well, the real part is 0. And let's see, the real part is 0. Here, the real part is negative 3 plus the square root of 3. For each complex number, identify the imaginary part. That would be 1/2. It's not the I, it's what's in front of the I. Here, that's going to be 1 minus the square root of 2. Doing good, folks. Doing good. All right. Number 8. Simplify each expression. Write your answer as a complex number. So when we're adding, we got to combine like terms. So we've got 2 plus 12i. The 4i and the 8i are like terms. Let's try that in the calculator. So you have 4i plus, and then what was it? 2 plus 8i. Open parentheses, 2 plus 8i. I, and then press enter, and you got 2 plus 12i, and we got 2 plus 12i. Number 9, again, you combine like terms. You have 2 minus 5, that's going to be negative 3. Negative 7 minus negative 3, that's negative 7 plus 3, that's going to be minus 4i. All right. And here, we have to multiply. 3 times 1 is 3. 3 times minus 12i. I times 1 is plus I. I times negative, that's going to be minus 4i squared. So I squared is the same as negative 1. So I'm going to have 3 minus, well, that's going to be plus 4. So that's going to give me 7 minus 12i. I multiplied and that's not 12i, that is 11i. Negative 12i plus I plus 1i, that's going to be minus 11i. All I did was combine the like terms. In electronics, the total resistance to the flow of electricity in a circuit is called the impedance, Z. Impedance is represented by a complex number. The total impedance in a series circuit is the sum of the individual impedance. The impedance in one part of a circuit is Z sub 1 equals 3 plus 4i. In another part of the circuit, the impedance is Z sub 2 equals 5 minus 2i. What is the total impedance? Well, that would be Z sub 1 plus Z sub 2, which is 3 plus 4i plus 5 minus 2i. And all we do is we combine like terms. 3 plus 5 is 8. 4i minus 2i is plus 2i. Not too shabby. Number 12. In a circuit, the voltage V is given by the formula voltage equals I times Z, where I is the current and Z is the impedance. Both the current and the impedance are represented by complex numbers. Find the voltage if the current is 3 plus 2i and the impedance is 4 minus I. So voltage equals current times impedance, which would be 3 plus 2i times 4 minus I. Well, let's see. 3 times 4 is 12. 3 times minus, that's minus 3i. 2i times 4 is plus 8i. And 2i times negative I is minus 2i squared. Well, let's see here. 12 minus 3i plus 8i, that's going to be plus 5i. And that's going to be minus 2 times negative 1. So negative 2 times negative, that's going to be plus 2. 12 plus 2 is 14 plus 5i. Not too bad. We got that one done. Let's move on to the third sheet. Solve using the quadratic formula. Okay. Well, a couple things we have to remember. Let's see. First, it has to be in standard form, and ax squared plus bx plus c equals 0. That's standard form. And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac. Let me clean that up. 4 times a times c all over 2a. So what do we got here? Here, I like to, well, I'm going to need a little real estate here. So what I like to do is first, I like to, what is a? Well, this isn't in standard form. Let me rewrite it in standard form. X squared plus 10x plus 9 equals 0. So a equals 1, b equals 10, and c equals 9. All right, good. So x equals, and that's going to be negative 10 plus or minus the square root of, That's going to be 10 squared minus 4 times 1 times 9, all over 2 times 1. So x equals, that's going to be negative 10 plus or minus the square root of, that's going to be 100 minus 36 over 2. So x equals negative 10 plus or minus 100 minus 36, that's 64. The square root of 64 is 8, all over 2. All right, so we got x equals negative 10 plus 8 over 2, which is negative 2 over 2, which is negative 1. You also have x equals, that's going to be negative 10 minus 8 over 2, which is negative 18 over 2, which is negative 9. Negative 9. So x equals negative 1 and x equals negative 9. Let's take a look at number 2. First, let's rewrite it. X squared plus 2x plus 4 equals 0. And we're going to change colors. We'll let A equal 1, B equal 2, and C equal 4. So x equals, that would be negative 2 plus or minus the square root of, that's going to be 2 squared minus 4 times 1 times 4. All right, all over 2 times 1. So x equals negative 2 plus or minus the square root of, that's going to be 4 minus 16, all over 2. So x equals negative 2 plus or minus the square root of negative 12 over 2. And it's going to be negative 2 plus or minus, and you're going to have the square root of negative 1 times, and 12, that would be 4 times 3, all over 2. So x equals, that's negative 2 plus or minus, the square root of 4 is 2. Square root of negative 1 is I. The square root of 3, can't do anything about that, over 2. If you notice, these 2's cancel out, and that gives you negative 1 plus or minus I times the square root of 3 over 1. So x equals negative 1 plus I times the square root of 3, and x equals negative 1 minus I times the square root of 3. So that's 1 and 2. 3 and 4. Three and 4. I do the same thing. Rewrite it. X squared plus 5x minus 3 equals 0. A equals 1. B equals 5. C equals negative 3. X equals negative 5 plus or minus the square root of, that's going to be 5 squared minus 4 times 1 times negative 3, all over 2 times 1. So x equals, that's going to be negative 5 plus or minus the square root of 25 plus 12 over 2. And it goes over there. All right, so x equals negative 5 plus or minus the square root of 37 over 2. Now, the square root of 37, I don't think there's anything you can do about that. So you're going to have x equals negative 5 plus the square root of 37 over 2. And x equals negative 5 minus the square root of 37 over 2. Good deal. What about number 4? Number 4 is actually easier. It is already in standard form. So you're going to have A equals 2, B equals 7, and C equals 10. All right. So x equals negative 7 plus or minus the square root of, that's going to be 7 squared minus 4 times 2 times 10. All over 2 times 2. So x equals, that's negative 7 plus or minus the square root of, that's going to be 49 minus 4 times 2 is 8 times minus 80 over 2. X equals negative 7 plus or minus the square root of, that's going to be negative, let's see, 31 over 2. Well, negative 7 plus or minus, I can take the negative 1 out, so that's going to give me I times the square root of 31 over 2. And that's all I can do with it. So I got x equals negative 7 plus I times the square root of 31 over 2. And 2 times 2 was 4. I almost dropped that. And that's 4. And that's a 4. Oops. And that makes that a 4. And x equals negative 7 minus I times the square root of 31 over 4. So that's number 4. 5. Find the discriminant of each equation, then determine the number of non-real solutions. So we're going to find the discriminant. Let's give this a little space here to write on, so I don't have to write over top of these letters. And let's see. First, I need to put it in standard form. X squared minus 3x plus 8 equals 0. Okay. The discriminant is b squared minus 4ac. It's what's found underneath the radical in the equation. So what do we got here? B squared, that's going to be negative 3 squared minus 4 times 1 times 8. Negative 3 squared, that's going to be 9 minus 4 times 1 is 4. 4 times 8 is 32. So I'm going to get my negative 23. Negative 23. So that's going to be 2 non-real solutions. Let's take a look at number 6. X squared plus 4x plus 3. All right. B squared, that's going to be 4 squared minus 4 times 1 times 3. 16 minus, well, 4 times 1 is 4 times 3 is 12. So I get a positive 4. Positive 4. Since that's above 0, I get 2 real solutions. That negative 23 was below 0, so I got 2 non-real solutions. And then here, let's rewrite this. 2x squared minus 12x plus 18. All right. So we got negative 12 squared minus 4 times 2 times 18. Negative 12 squared, that's going to be 144. All right. And minus 4 times 2 is 8. 8 and 18, that's 64. 6, that's 144. So I get 144 at 0. So that means I'm going to have 1 real solution. All right. Number 8. Oh, it's a party now. Complete the square. Complete the square. Number 8. X squared minus, what do we put in this box? We put in that box b over 2 squared. So that's going to be negative 4 over 2. That's negative 2. Negative 2 squared is 4. Well, what does that tell us? That would be x, and b over 2, that would be negative 2 squared. There we go. Here, we're going to 12 divided by 2 is 6. 6 squared is 36. So we're going to have x plus 6 squared. 25 x squared minus 10x plus 1. So what are we going to put in the box? Well, now this b over 2 squared only works if you have 1 in front of the x. So what are you going to have to do? What are you going to have to do? You're going to have to divide. Okay? You'll end up with 1 here. So you're going to have 5x minus 1 squared. All right. Solve each equation by completing the square. Number 11. Number 11. Let's scoot this up. Scoot this up and get us a little writing room here. Haven't done that in a long time. And let's get us a little writing room. There we go. Okay. So what do we got? We have x squared plus 2x equals 3. Now what we're going to do is we're going to add b over 2 squared to both sides. So 2 divided by 2 is 1, and 1 squared is plus 1. Plus 1 and plus 1. That's going to give us x squared plus 2x plus 1 equals 4. Now we can factor that as x plus 1 squared equals 4. We take the square of both sides. And that gives us x plus 1 equals plus or minus 2. So x equals negative 1 plus 2, which is 1, and x equals negative 1 minus 2, which is negative 3. So we got x equals negative 3, and x equals 1. Number 12. Number 12. What do we got here? We have 2x squared, and I'm going to subtract 10x, and then subtract, we'll just leave 8 over there, equals 8. Now, I got a 2, a 10, and an 8. 2 goes into all of them, so I'm going to divide each by 2. All right, so I get x squared minus 5x equals 4. Now I'm going to add b over 2. That's going to be 5 halves squared, so that's going to be plus 25 fourths. I'm adding, that's this right here. I'm going to add this, and that's going to be 25 over 4 plus 25 over 4. And that's going to give me x minus 5 halves squared equals, now 4, that's the same as 16 over 4, right? 16 plus 25, I get is 41 over 4. Now I'll take the square root of both sides, and I get x minus 5 halves equals, and that's going to be the square root of 41 over 2. All right, add 5 halves, so x equals 5 halves, and that's plus or minus the square root of 41 over 2. So x equals, and that's going to be 5 halves minus the square root of 41 over 2, and x equals 5 halves plus the square root of 41 over 2. That's your solutions for 11 and 12. 13 and 14. we're going to do something very, very similar. There we go. All right, so it's already over there. I'm going to divide everything by -3, and I'm going to get x squared minus 6x equals 10. X squared minus 6x equals 10. Now we're going to add b over 2 squared. So that's going to be plus -6 over 2, that's -3. -3 squared is 9. So we're adding 9 to both sides. And that's going to give us x minus 3 squared equals 19. So we take the square root of both sides. And that gives us x minus 3 equals plus or minus the square root of 19. Add 3 to both sides. You got 3 plus or minus the square root of 19. All right, let me get this out of the way. So x equals 3 minus the square root of 19, and x equals 3 plus the square root of 19. 14, first I'm going to move the 12x. So I got 4x squared plus 12x equals 4. Notice I've got multiples of 4, so I'm going to divide by 4. Then I got x squared plus 3x equals 1. Now I'm going to add, that's going to be 3 halves squared, so that's going to be plus 9 fourths. So that's plus 9 fourths. And that's going to give us x plus 3 halves squared equal, and 1, that's the same as 4 over 4, so that's going to give us 13 fourths. Take the square root of both sides. Now this ain't hard at all, is it? So we got x plus 3 halves equals plus or minus the square root of 13 over 2. Subtract 3 halves from both sides, so you got x equals -3 halves plus or minus the square root of 13 over 2. So x equals -3 halves minus the square root of 13 over 2. And x equals -3 halves plus the square root of 13 over 2. Not too bad. Let's take a look at number 15. The height in meters of a baseball t seconds after it is hit straight up in the air with a velocity of 45 meters a second is given by h equals -9.8 t squared plus 45t plus 1.2. Will a baseball hit straight up with this velocity hit the roof of a batting cage with a maximum height of 64.5 meters? Use the discriminant to explain your answer. So what I'm going to say is -9.8 t squared plus 45t plus 1.2 equals 64.5. Now to use the discriminant, I'm going to have to subtract 64 from both sides. So I got -9.8 t squared plus 45t plus, oh, that's not plus, that's minus, and I get 63.3. And that equals 0. All right, now I can use the discriminant. So b squared, that's going to be 45 squared minus 4 times a, that's -9.8, times c is -63.3, and that's not going to equal 0. We're just, what is that going to equal? 45 squared is 2,025. Now, no, I didn't do that in my head. I used the calculator. And then we got negative, negative, and negative. So that's going to be minus because negative, negative is positive, and positive, negative is negative. 4 times 9.8 times 63.3 is 2481.36. So our answer is negative 456.36. That since the answer is negative, we're going to say no. All right, it will not reach. Good job, folks. You have a great evening, and good luck on the test tomorrow.